Upskill your marketing team with Asia Pacific Institute of Digital Marketing. We offer a wide range of digital marketing courses and corporate training programs for all types of industries. Learn from the best industry experts with multi-market experience. Call 32277 or visit www.apidum.lk today. Upskill your marketing.
Hello and a very good evening to all of you. Welcome to this next webinar of the Asia Pacific Institute of Digital Marketing. In fact, even though I mentioned it as the next webinar, this is going to be a short course. This is the very first time that we are doing a 3-episode webinar series on the same topic. We've been conducting these webinars, free webinars, for nearly 6 months now. Starting from last year, August, or even before that, we've been doing these webinar trainings. But for the very first time, we are going to do a 3-episode webinar short course on the topic of Internet of Things, so IoT. And I have to tell you that we have a record audience today. Right now, I'm seeing 106 participants. So this is the very first time that we have exceeded 100 participants for any of our webinars conducted. So thank you very much for taking time to join with us. And I have to tell you that it's going to be a 3 episodes short course. So I'm expecting you to continue this right throughout the entire 3 episodes today, Wednesday, and on Friday. All right. The topic for today is Internet of Things, IoT. And I'm no expert of IoT. I have nothing to talk about IoT because that's not my forte. But just as with any other topic where Asia Pacific Institute of Digital Marketing is bringing to you, we get the best in the industry to talk about the topics. That's usually the case with any program the Asia Pacific Institute of Digital Marketing is conducting. So for today's session, today's program on Internet of Things, we have such an elite panel of experts from the industry to talk about this topic. I'm going to introduce them to you in a while. But before that, let me tell you that this program or this short course is brought to you by in association with Zone 24/7. So they are our knowledge partners. All the panelists for this program is represented by that company, Zone 24/7, and I'm sure they'll share a lot more information about Zone 24/7 when they start their presentation. Before we get to the introduction about our panel today, the presenter panel today, let me quickly share a news from Apidum with you. That is our next intake of the professional diploma in digital marketing starts on 30th May 2020. You know, we've been conducting this program, professional diploma in digital marketing, for 14 batches since 2015, and more than 300 people have completed this professional diploma in digital marketing. Presently, we are catering to the batch number 13 and batch number 14. They started as usual typical classroom session, physical classroom session, but with the present condition in the country and across the world, we converted all those classes into virtual classrooms like this. And for our next intake, what we are going to do is we are going to convert it as a 100% online delivered course. And with that, we are going to bring down our price as well. So the course is usually priced at 89,500 for the 6 months program on digital marketing, and we are bringing it down to 58,500 for one-time offer for whoever who is going to join or register for this program. So if you are interested, or if you know anyone who would be interested in this program, please contact Apidum on any of the numbers mentioned here, or just drop an email to info@ Apidem, that's apidm.lk. apidm.lk, info@apidem.lk. All right, so that's about us, that's about Apidem and our programs. Now let's get straight to the introduction about today's speakers. As I said, the entire panel for this evening for this topic of Internet of Things represented by one company who is our knowledge partner today for this program, that's Zone 24/7. And our first speaker for the day is Asanka. Asanka is currently working as the Director, Chief of Staff at Zone 24/7 with a proven ability to groom engineering teams in order to maximize company profitability and efficiency. He further owns more than 15 years of experience in working with customers in USA, Norway, Malaysia, and Sri Lanka, managing delivery of cutting-edge technological solutions. So Asanka is our first guest today. Asanka, please come on screen and greet your audience.
Hi everyone, hope you can hear me clearly. I'm really glad to have such an enthusiastic crowd because I can already see some questions coming up. So looking forward for a good discussion.
All right, great. Thanks Asanka. And let me introduce our next speaker or next panelist today. Is none other than Heshan Pereira, the architect or manager IoT at Zone 24/7. Heshan currently works as the architect and manager IoT platforms at Zone 24/7, and he has years of experience in the field of product management, remote monitoring and management, software architecture and delivery management targeted at top tier retailers in the US. Also as a lecturer, he disseminates his knowledge and expertise in software engineering, information security and IoT. So Heshan, please come on screen and greet our audience today.
Everyone, nice to be here and hope it will be a fruitful session for you. And like Asanka said, really happy to see questions already popping up. So let's have a good one.
Perfect. And the next speaker for the day, that's going to be Isuru Samarasinghe. Isuru is currently working as the engineering lead at Zone 24/7, and he is an experienced software engineer with a demonstrated history of working in the computer software industry. Further, he's skilled in Java, EE, SQL, and MongoDB, Node.js, AngularJS, Spring, Hibernate, requirements analysis, and JMS. So I'm sure Isuru is going to explain all that because I have no clue because I'm coming from the business and marketing end, but I'm sure there'll be a lot of joining in today from the audience who are pretty much familiar. So Isuru, please come on screen and greet the audience.
Hello everyone. So let's have a good discussion about IoT and this stuff.
Perfect. So guys, our lovely audience today, we have the panelists introduced. So we are going to start this discussion in a while. I think we are going to start with Asanka, right? Before that, let me actually give an introduction to this entire thing. Now, Internet of Things, it's becoming a hot topic. It's already a hot topic for several years now, especially in the technical field, technological field, the engineering field. But in terms of in Sri Lanka, the business usage of IoT, how businesses are adapting these technologies to their day-to-day operations is a bit of a question mark. So that's why the Asia Pacific Institute of Digital Marketing decided to do this course, particularly to uplift the knowledge level of the business and marketing community in Sri Lanka about IoT, so that when you know the technology behind it, it's much more easier to actually think about use case scenario. So with that, I'm going to hand it over to our first speaker today. Please enlighten us about what is IoT, what is Internet of Things, and from there we'll start our discussion.
Sure. So Amita, first let me start by sharing my screen.
Sure.
Yeah, trust everyone can see my screen already, right? Great. So before we get started, I'd like to give a quick background about Zone 24/7 and why we are here talking about this topic today. So Zone as a company is a very unique company in the sense that it is one of the few organizations that can deliver expertise right from hardware to electronics design, right up to consumer-facing software. So as a result of this, the Internet of Things was a natural progression and a natural domain for us to enter. And we have been in this implementing some of the most cutting edge solutions for very forward thinking retail as well as logistics customers in the US. Of course, we're into many other domains, but our IoT has been primarily focused on these domains. So today, as Amita mentioned, it's going to be a 3-part series. And on Amita's request, what we're going to do is we're going to spend a lot of time introducing everybody to the concept of the Internet of Things. And today it will be mostly myself and Asanka who will be doing the talking. So I'll be covering the part of, hey, what is the IoT or what is the Internet of Things? A little bit about how it works and what are its benefits at a very high level. And then of course, Asanka will be taking it further and giving you information on something very important about how do you decide whether the Internet of Things is for you? Is it something that you feel that you can derive benefits from? And as well as talk about some examples of where it has been applied, right? So let's get started. Right, so in a nutshell, the Internet of Things is a state of technology, right? So this is a very heavy word and this is what we'll be spending most of our time on. So when I say, so it is basically the current state of technology that enables it to sense, then make sense of what it senses, and act on the physical world at scale, right? So at scale is another very important aspect of it, meaning we can now do it at millions or trillions of levels of interactions and devices and basically span to a large territory of our world today in terms of how we sense it and then of course make sense and act on it, right? So I said, so this is a very different definition. So let's look at what I mean by the state of technology, right? So if you've been following IoT, if you've been following tech even a little bit, you would have seen that we are now able to fit greater computing power into smaller spaces while having a lot of power efficiency. What do I mean by that? So you can see the background image. I'm talking about being able to fit computers that can make fairly intelligent decisions at the tip of your finger. And at the same time, consuming very low power, meaning it could probably run for months or years on a small battery, right? So what does this mean? What are its implications? Meaning we can now fit computers into places which we never could. Practically, we could fit a sensor or an actuator. An actuator is something which allows you to actually take action and interact with the physical world. You can place this on practically every leaf on a tree, right? Maybe exaggerating, but just to put things in context. So when things are smaller and more power efficient, that allows to put these things everywhere. And in other words, help us to sense digitally the world in a much broader scope. Right? The second state of technology that has enabled the Internet of Things is the ever-expanding wireless communication networks, which are becoming faster and ever more power efficient. So what I mean by that is, if you take Sri Lanka currently, 78% of Sri Lanka has data coverage today. If you take the US, 91% of it is covered through data. And this is increasing with time. And what this means is there are more regions of our planet, of our Earth, which can now communicate information digitally to other computers in the world. And this creates the room for massive synergetic effects, where a lot of sensors, a lot of components that can be placed in barren deserts, dense forests without humans needing to be there. It means that we can safeguard humans from not having to enter dangerous environments, to monitor as well as to sometimes manipulate those environments to keep humans safe or even make use of business opportunities. So these ever-expanding wireless communication networks are a huge enabler of the Internet of Things. And at the same time, like I said, they're becoming faster. We can now transmit even video data at very high rates. Hey, we're having a large-scale Zoom meeting today. All of this is evidence of the speed and the volume that these wireless communication networks can support today. And at the same time, they're becoming very power efficient, which in turn benefits the first aspect which I spoke of, where computers themselves need to spend less power in communicating this data, and which leaves them more power to make decisions, to analyze information, and utilize their batteries to enhance their lifespan within the wild, right? The next, I'm sure everybody knows about this, cloud computing and cloud infrastructure. Well, how does this really make sense, or how does this relate to the Internet of Things? As you may have gathered by now, the Internet of Things is all about millions, trillions of sensors sending out data. And in many situations, this data is analog data, which needs to be transferred into digital data. And analog data is usually transmitted at very high rates, which means that you could be having terabytes of data per second per hour being generated, or petabytes of data being generated per day, right? So there's no point of having this data if you can't process it. So for you to process it, you need computers. And the traditional way of thinking about this was for you to have your own set of servers in-house, have your server room, hire a large systems team, think of your own disaster recovery and fault tolerance so that if one of your computing sites go down, you can resort to a backup site. But all of this requires a lot of investment, a lot of down payment, even before you get into an IoT scale project. And this creates a major barrier to entry for many organizations, even to try things out. Today, cloud computing has a couple of characteristics about it, which make it far more attractive to creating Internet of Things solutions. One, you don't need to worry about the disaster recovery and the fault tolerance of your computing infrastructure. Cloud providers such as Google, Amazon, Azure take care of that. And the second most important thing is you pay as you go. You don't make any major capital investments. You only use it as and when you need it, which means your risk is far lesser. So the minute you don't need it, you just stop your subscription then and there, and you haven't lost anything, or you don't lose anything that you're not using, right? So this is a major enabler in terms of providing that compute capability. Now, we've spoken of three aspects. We've spoken of our ability to put computers into practically every nook and cranny of the world. We've spoken about the advancements of wireless communication, which makes it possible for us to have connectivity and have these computers placed in remote locations, as well as transmit data back to our motherships like clouds in order to make decisions back there, right? And we've spoken about how computing power is no longer a very expensive commodity, but rather it's something that's affordable, and how cloud computing has reduced the risk and the amount of capital expenditure involved with acquiring compute power, right? So you've got the compute power and you've got massive amounts of data, but still being able to process petabytes and petabytes of data in a timely manner. So what I'm saying is you may receive a large volume of data, but you shouldn't have to wait weeks or months to get a decision out of it, to make analytics out of it. Big data engineering is something which solves this problem for you. So for years, big data engineering has been advancing. It's been trying things out in the real world, and it has come up with repeatable models and even tools and techniques that can be easily utilized by teams that are implementing IoT scale data analysis and processing problems, right? Who are solving these kind of problems. So without the world of big data engineering and all of its advancements, today we would not be able to, or rather if you were engaging in an IoT problem, this would be a massive problem which you'd probably have to spend months and months trying to solve in terms of how you, for example, process this data parallelly. So big data engineering has been a major enabler in this Internet of Things. So now we are able and we have techniques that can process data. But how do you enable a computer to make complex decisions, complex inferences, right? Anybody who has any background in programming or has tried their hand in writing any code will soon realize that, hey, when I make a decision in real life using my eyes and ears and touch, I may actually go through a million conditions and thousands of memories before I actually make that decision or make that inference. Imagine trying to program that kind of logic into a computer and allowing it to make decisions that are repeatable and consistent when you provide it with slightly varying data. That's an extremely complex problem and not something that, especially as a programmer, that you would really want to get into. But then again, that is what we really need in order to make use of the Internet of Things. And something that has really brought us forward and something that has really excited the use of the Internet of Things is this concept of artificial intelligence. It's got many branches associated with it, many forms of implementing it, such as machine learning, deep learning, even data science is a branch of it and an aspect of artificial intelligence. So what has happened? People have got really good at this. They've tried it again and again on varying data sets, and they've come up with common tools and frameworks. And when these tools and frameworks don't exist, they have come up with great training material that describe how you can train computers to make decisions out of a large number of parameters with complex relationships. That may be a lot to process, but keep this in mind. What you can do is you can relate this to how your brain actually works. And it, in a nutshell, may cover this. This may be a simplistic form of that. And that is what we're trying to mimic. And the field of artificial intelligence has advanced in the level where not only can it solve complex problems, it's enabling other users as well, such as ourselves, to not fall in the same traps, the same loopholes, sorry, the same holes. And for us to kind of be able to stand on the shoulders of giants and look further and deliver great intelligence through these frameworks and material that is available for us today, right? Okay, so what have we covered so far? We know we can put computers everywhere. They're extremely small, extremely power efficient. We know that we can reach these computers thanks to the advancements of these wireless communication technologies. We know that the compute power can be obtained without having to put a lot of capital investment onto it and using pay-as-you-go models with cloud computing. We know that we can process this data in a timely manner using big data engineering and all the advancements and tools that have come out as a result of that science. Then we figured out that artificial intelligence domain has left a lot of footprints, tools and frameworks that enable us to make really intelligent decisions with this data that we capture and that we can now process. Finally, the IoT platforms have come out where they allow us to quickly connect devices and visualize them. So you, as somebody who's implementing and trying to prove a concept, everything starts with proof of concept, right? So for you to get your proof of concept going quickly, for you to show this data to the senior decision makers who are funding your project, IoT platforms are a major enabler. They enable you to bootstrap your project really fast, not only the visualization, but also implement rules like if this, then that. So if this happens, if this data is received, then do this. Example, you have a temperature sensor, it's reporting a temperature that is going beyond a certain threshold. You can, through a few drag and drop operations on your IoT platform, you can basically say, okay, if it goes above a threshold, then trigger the connected AC in that room, for example. And coming to the topic of AC, connected AC, organizations, so these are home appliance vendors, all forms of equipment vendors are now ensuring that their devices have some form of connectivity. If any one of you have heard of the Tesla, or even take the Toyota Prius today, these receive software over-the-air updates. And this is evidence that devices today are readily integratable, which allows us to create use cases, solve a lot of business problems using them and create the whole value out of the Internet of Things, right? So we've covered what the Internet of Things is. We've covered what has made it something that is possible today, but why? Why should we get into it? So there are two high-level answers. One is obvious, right? You've got more information and control, and important, you get it at a low operating cost. Why do I say this? Humans are good at creative work, but when it comes to mundane, repetitive tasks, not all that great. Why? One thing is they get bored. We have this term called human error because there's always this tendency for us to make errors. And when you have a mundane, repetitive task, the whole point is there should not be errors in it. Whereas computers, on the other hand, are highly efficient when it comes to executing such mundane and repetitive tasks. And when you ask them to do something, they just do it, right? At the same time, when you deploy human to do a mundane and repetitive task, you've got to pay them salaries, right? And at the same time, you're not making the best use of a human, which is their creativity. We're the ones who make machines. We're the ones who actually create all this technology. And why should we be out there doing some things that is mundane and repetitive? We've built machines to do that. That has been what we've achieved through every stage of our industrial revolutions, right? So through deploying machines, organization gain two fundamental benefits. One is they eliminate the recurring salary costs of humans in mundane jobs. And you're able to relocate humans, cross-skill them, upskill them, get them to do creative work. So more information and control because you can deploy these things all over the place at a low operating cost. Second, again, another obvious thing, better and faster responses. Why better? Your decisions now are made through actual data and a whole load of data that is coming from the real world. You can apply concepts like machine learning, deep learning, data science, basically all forms of artificial intelligence, so that you can make intelligent inferences through all this data that you get. So better decisions. Computers can now, out of those decisions, since computers are making those decisions and presenting them to you, they might as well take action as well. And it's very easy today. For example, take sprinkler systems today, which are activated based on the humidity of the soil. And take scenarios where we can trigger alarm systems. We can trigger fail-safe mechanisms when equipment is about to fail, right? So autonomous and immediate actions enable us to make extremely fast responses, saving lives and bringing in a whole load of efficiency, right? So that is the gist of what I wanted to cover today. So we've covered what it is, we've covered how it has been made possible today, and in summary, why it is important and in a broadly applicable sense. So now I'd like to hand over the controls to Asanka to talk about its use cases as well as how you can make decisions on whether the Internet of Things is for you. So Asanka, over to you.
Thanks, Ashan.
Okay, let me quickly interrupt while Asanka get ready with his presentation deck. Guys, if you have any questions so far, you can actually type in your questions to Q&A box. You can see it on your toolbar. Just type in your question and our panel will take the questions as we go along. And anyway, towards the end of it, we have close to about 10 to 15 minutes, 100% dedicated for taking your questions. So keep the questions coming in, then we'll take those towards the latter part of it. So Asanka, over to you.
Okay, thanks, Amita. So good evening and good morning or good afternoon, depending on where you are connecting today. So when you're talking about, actually, Hishan was covering the fundamentals of IoT and the benefits of it. So before we talk about like whether we should invest in IoT, right? Let's have a look at about the history, like how it has been so far, because we know like IoT came as a huge hype, right? So actually the total credit should go to Cisco on creating this hype for IoT, because in 2014, they claimed at the CES show that IoT is going to be a $19 trillion opportunity, right? However, after that, interestingly, around 2017, a research organization in UK, Beecham Research, they conducted research on multiple giants like the Cisco, IBM, Microsoft, etc. And they found some interesting results. So I'm just taking here only the results from Cisco, but the Microsoft and IBM also mostly the same, right? So what they did was like they took about 1,845 businesses across United States, UK, and India, and they took a survey on whether the projects which are started are successful or not. Interestingly, like Cisco itself claimed out of those 1,845 projects, like only 26 projects are successful, right? Then here are the next interesting facts. Now they are providing their services to some other the receiving party, right? Some other organization. In that organization, IT executives claim out of this 26%, if you take 20% as a whole, only 35% of that projects are successful. Then in the same organizations, the receiving organizations, they are claiming out of this 26%, only 15% is successful, right? So this tells you the success rate of those IoT projects, right? So Amit, I think in about 3 minutes, I covered like whether we should invest in IoT or not, because it shows like the results, right? So yeah, but having said this, now these are research, right? So it comes with some the people input as well as the people thinking. So the interesting is like when you look at this research, the IT executives of these organizations, what they had looked at is mostly about the technology and the vendors who are supplying this technology, etc. And at the same time, from the business executives' point of view, what they are looked at is the business case, the strategy, and the milestone. So likewise, their viewpoints will be different. However, what Cisco is claiming, 26% remains same. So next 10 to 15 minutes, my target is to like take you all through because IoT starts as a hype, right? So how we could take this from hype to reality with the right business model. So that's my goal, which I'm going to achieve here, right? So moving on. By the way, I hope you all can see my full screen, right? Just want to make sure. Okay. So now when we're talking about investments, I saw like there are a lot of financial and banking questions also coming in. So I'm sure this will be interesting for you as well, right? So when it comes for investment, the first thing that you look at is what's the return, right? So most of the time return comes with a monetization model. So with IoT, like there are a few key areas or rather challenges that people face when it comes to the monetization. The one is this obvious reason, the security and privacy concerns, right? Because we are talking about connecting all the data, the personalized, even the personal life will get connected. Like you can see like homes are getting connected. So if some system can look at, if I can look at my home remotely, then the next question is like whether someone else also can look at it. So likewise, there are privacy concerns. Then other one is on the revenue part of it, like what kind of models that can be applicable to generate a revenue, because I'll be touching this one on my next slide as well. Then the other aspect is when you're trying to build some IoT ecosystems, you have to come up with multiple, you have to acquire different skill sets. For example, let's say if you are really good in developing certain hardware, you may be good in embedded systems and electronics, so you can build up a sensor platform. However, if you are talking about IoT, it talks about like deploying these sensors in multiple locations, right? And maintaining it. So although you are good in developing the hardware, you may not be good in running a maintenance crew of hundreds of people who will deploy into multiple locations and doing the maintenance, right? So either you have to acquire that skill set or else you have to partner with another person. So those are the different challenges people face especially when it comes for monetization of IoT. Moving on. Now, these are some of the revenue models that the people had tried out, right? So on my x-axis, what I'm covering is the monetization models, right? Whether it could be the basic to advanced. Then on the y-axis, what I'm covering is about the relationship with the customer, right? So there are primarily 4, and there could be more as well, right? So the first one is about the hardware premium. Basically, you build an IoT gadget and you sell it more like a kind of a transaction, right? You sell it at a certain, build at a certain price, and you sell it at another price, and that's it. But with the IoT, like there are other models which are coming up. You are not trying to sell the hardware, but you are trying to sell a service on top of it, right? So that's where the service revenue comes in. Then the data revenue is like you deploy sensors or deploy systems to collect the data, and you try to do some analytics on top of it, and you sell those analytics back to the customers, right? So that's where you get the data revenue. Then on the ecosystem building, this is where you are building a platform where you are trying to get the revenue from the product vendors as well as from the end customers, right? So it's more of kind of a collaborative approach that you are looking at. So likewise, there are different options which people had tried, especially when it comes for monetization of this, right? So let me take you through a few use cases which like look interesting to me, because if you even search for some use cases, I'm sure you can find a lot in the internet. But the areas that I'll be covering are like which are of some interest. Like the first one is about this Internet of Oysters. This was deployed in Australia, right? For basically like for any business, like it runs from the common sense of the business leaders, right? So they are doing some guesswork and they are doing like running the business. Now with IoT, what it enables is like with the collection of data and the right analytics, it can predict better than the average human. So that's where the advantage is. So that's why I said like it's the guesswork to the exact science. So here, what the main problem that this oyster business that they face is, especially in Australia, like during the rainy seasons, or like if there's a heavy rainfall happens, right, the water will get contaminated, and there are some regulatory standards where they are not allowed to. They are basically requested to destroy all full of their harvest because of the water level contaminated with and it could have some adverse effects on the human's health, right? So this sudden closure of their harvest is a huge impact on their financials. Right? So what the IoT system does is like they deploy sensors to collect the data and predict the changes and take the right decisions, like when to plant, when to irrigate, when to feed, etc. And the savings of this solution was in millions, and they had saved about 7.6 million per year, especially by reducing the wastage, right? The next example that I want to like share with you, right? This is about the city tree, right? So I'm sure like you had seen the different sensors about capturing the air pollution, and sometimes since financial people are there, like there are some systems which will capture the air pollution, and they are changing the highway charges based on the air pollution, so that they can do some controlling of the incoming city traffic, right? So likewise, there are multiple solutions out there. And at the same time here, what they're trying to do is like they are trying to use the moss and control the moss plants there to the exact climate to survive using the sensory data. And they have their special the watering systems, and all the control systems work based on the analytics that the sensory data is collecting. And the interesting part is like these these systems are taking 99% of the, like less than 99% of the space. And the impact of this is like they can have about over like 200 urban trees, right? So I think about 270 urban trees, the same effect that they can create using this on cleaning up the air, right? And of course, in Sri Lanka also, like there are IoT implementations that were done, like some farms, they had tried out like using the drones to capture where the weeds are growing, and using targeted the fertilizer feeding so that they can eliminate of these weeds. And at the same time, there are, you might have seen like the smart homes which are coming up with all the connected features where you can control everything from a smartphone, right? Yeah. So now, if you are interested in investing IoT, right, I would like to take you through some thinking process. Right? The first one is about the planning stage, and other one is about the implementation stage. So these points are in my opinion, and I would like to have a discussion after this, like if you have any further points to add to this, or like if any criticisms as well, right? So the first point that I want to share is like during the planning stage, like define the problem clearly and try to work out the benefits by solving the problem. As you can see in the oyster scenario, like they knew the problem of their wastage, so they had worked out the savings, right? And here the key point is like, do not follow a hype. Because we had seen in 2014 to 2017, people had tried to follow some hype and they had failed, right? So we don't want to repeat the same mistakes, right? Do not follow hype, try to find the right problem and work out the benefits by solving that problem. That's the number one. Then know about the regulatory limitations, because especially when it comes to IoT, you are talking about some connected devices and wireless communication. And based on the region, based on the country, there are certain wireless regulations are applied, right? Because certain RF frequencies are not allowed. You are not allowed to bring in certain equipments. Likewise, there are different regulations in place, right? Even sometimes if you are using some video captures, there are certain regulations like the GDPR and all, where they are limited to save some the personalized information as well, right? So likewise, know your regulatory limitations, because it was successful in one country, it doesn't mean you can directly bring it here and apply it. It doesn't work like that. Right? The third point is understand the dependencies of your total solution, because as I said earlier also, like you might be good in developing certain hardware, but in order to have the complete system to function, you need to have the complete ecosystem. You might need to have the connectivity medium, and you might have to have the backend data servers and the analytical engines likewise. And you may need to have some maintenance people to do the maintenance likewise, right? So understand the total dependencies of your system. Then the last but not least, because this is one point which people ignore, like especially when it comes to the initial, the revenue, the cost calculations, they calculate up to the implementation and deployment of it, but they tend to ignore the maintenance cost. Because especially when it comes to the IoT, like because these sensors or equipments will be deployed across different locations, you have to have some regular maintenance to make sure like these systems are functioning correctly. So calculate those maintenance costs as well. So those are the things that you can look at, especially when it comes for the planning stage, so that you will know like what kind of cost elements are there, and at the same time whether it's doable, as well as what are the benefits. From that benefits you can work out what kind of ROI that you can get, right? So that's at the planning stage. Then on the implementation stage, here these are mainly focusing on like how we are going to implement it, and a few areas to focus on. First one is the right connectivity method for the data, because in IoT, like based on the sensor data that you're going to capture, there'll be different connection mediums that you will need, right? So in a kind of crude example, what I can say is like, if you don't build a highway, and if your expectation is to send only 3 wheels, right? And at the same time, if your expectation is to send a 40-foot truck, don't plan on building a gravel road, right? So that's the simple example that I can share about the connectivity and the data. So you have to make sure that the right bandwidths are available, right? Then focus on the edge computing, because in IoT, most of the time the processing will happen at the edge. So you have to make sure that we are using the right platforms so that the right devices are used, so that those will be durable and giving you the accurate data. And at the same time, on the analytics part of it, like make sure you are using the right data science techniques and the right data science approaches to make sure you are deriving the right analytics. Because it's in vain if, although you develop the entire system and you collect all the data, but if your analytics are or your predictions are wrong, then the whole purpose will be lost, right? Then the third point is, when you deploy these sensors or equipments, right, your business decisions will be taken based on some sensory data, right? So if the sensors are not functioning properly, obviously the business decisions that you're going to take at the end will be wrong, right? So you have to make sure these, whatever the things that you're going to deploy are remotely monitored and managed properly, right? So that you can depend on the data which is produced by those sensors or the equipments. Then the last point is make sure you have the right level of security. Here I want to emphasize the point on the right level, because sometimes you'll be deploying very less computing power equipments based on the type of data that you want to capture. So you don't want to overkill that system with loading so much of security or the encryption or whatever, right? So that's going to be your overkill. So you have to understand what type of security that is required and make sure it's guarded properly. So it could be at the edge level or it could be at the periphery. Likewise, how you are going to apply the security will vary depending on the case by case, right? So those are the things that I want to share with you all. Like, so if you take these points into consideration before you doing any investment in IoT, especially at the planning stage or at the implementation stage. So implementation stage, you may be doing it by your own or you may be doing with a partner. So if you are doing with a partner, make sure that partner is looking at this or focusing on these aspects. And if you like do this homework properly, I'm sure like you can have a good success story in IoT. So those are things that I want to share, and I'd like to take any questions. Myself and Hisham would like to take any questions. Yeah, thank you.
Okay, Sank, I think you already covered some of the questions from the Q&A box in your presentation. But if you go into the open questions, Ishan, please see, are there any things that you want to pick in particular?
Yeah, so there is a question about what is the future of online banking with IoT. So one, and Asanka, so we can add to this as well. So one obvious use case that comes to mind is the aspect of KYC or know your customer, where now organizations are looking at how they can even authenticate and identify that this is the real customer without the customer necessarily having to visit a branch. So these kind of use cases, since everybody has phones, are things that can be tackled through vision and AI-based technologies. So when it comes to online banking, that is one use case that comes to mind. And yeah, apart from that, there's a question saying even on those data, is IoT hardbound to any measurement related data? Well, usually underlying, if you really look at it, there will be some form of measurement or the other, because to generate an event, you are obviously comparing something against the other. But if you look at it from a a higher level. So for example, I'm in a room right now, right? If your use case basically depends on whether there is somebody in the room or not to turn off lights automatically, then there necessarily isn't measurement from a business case point of view, right? You're not taking any data and making any measurements explicitly, but the sensor would obviously be doing measurements inside for it to detect whether somebody is there or not. But from a business or a developer's point of view, I don't think it always has to be hardbound to measurement.
Yeah, Heshan, that's a very interesting question. I think you're going to cover this maybe in the Wednesdays or Friday session. The question is, what is the use of IoT in a time like this, example, COVID-19? I think in our preliminary discussions before this, in preparation of this program, we discussed this topic, right? So,
yeah.
Would you want to tackle that question now? Yeah.
Yeah, sure. I mean, of course, we'll get into detail in the relevant session, but in a nutshell, especially in COVID-like situations, we are working from home, right? And when you're doing that, especially your support engineers. So next week is going to be a fairly interesting topic where we'll be discussing, the title is Keeping the IoT Alive, where it's all well and good, like Asanka said, we can deploy this. But the next thing is, hey, you've put machines there, you need to be very sure that your machines are doing what they're supposed to be doing, that they're functional, right? So doing that, you have the whole concept behind remote monitoring and management, where you need to know what sensors are working. If they're not working, then what's wrong with them, and also try to remedy the problem if there is actually a problem. So you usually have a support operation to do that. It's not a big one, but you have one. But when these support teams are forced to work from home, if their tools are not efficient, then you have a bunch of problems associated with that because of the need for a lot of back and forth communication, bandwidth related problems, where your home bandwidth is far less compared to what you get in office, right? So those are some of the situations where this remote monitoring and management has to be very lean. And this is especially a situation where you need to relook at those strategies and your tooling. But in a nutshell, those are the aspects that really become important that we need to look at. But in that session, we'll get into details of what these tools should have as characteristics.
And there's this another question about the job opportunities for applied science graduates in the area of IoT.
Yeah, let me take that, Amita. So especially like the question is about the IoT and image processing and what kind of job opportunities. So here the main thing that I want to share is like when it comes for the edge processing, right? How we are going to take the real life information, convert into digital is always a science problem. Like it could be, let's say, especially when it comes for the image processing, right? So let's say if you want to do some traffic counting, or if you want to know like how much of traffic which is moving up on, and at the same time, even on the COVID, you had seen like you are trying to use some thermal images to capture the people, the heat levels, right? So that's also another science problem. So likewise, especially in the image processing area, and there was another question which was asked before also, like whether we can save the personalized information. One of the questions, and I said like I'll answer it later on. So there, what I want to share is like, especially when it comes to the data science, of course, saving the personal information is a question, right? Let's say if I'm Asanka has visited this place and this is my track record. Like if you have information in that fashion and these are my spending patterns, that's a problem. But for the data science, what it needs is not whether it's Asanka or Heshan, what they need is a male and in the age band of 30 to 40 and likewise. So the beauty of this is like we are eliminating the personal information, but we are maintaining the data which is required to generate the right analytics. So again, connecting with the know your customer, the online banking areas also, like how the world is adapting these technologies is eliminating the personal information, but capturing the right information which are required to generate the analytics, so that when a next person comes in order to provide those analytics, we have the right data at our hand.
Perfect. And there are like two questions which I would want to actually like to couple it as one question and put it across. Maybe like the two questions are, what are the IoT applications in telecom industry in Sri Lanka, or rather in general in telecom industry? And the other question is, what are the real examples of Sri Lanka with IoT? Maybe from telco, if you can take this Sri Lankan example, then you answer both the questions, or else you can tackle it as two questions.
Yeah. So I think in terms of Sri Lankan examples, Asanka already covered a few, especially related to the agriculture, right? And also, I mean, if you really look at it from a broad-minded perspective, you'll see how the latest shopping malls in Sri Lanka are using very efficient systems when it comes to parking. So that is also a typical IoT solution where it's sensing the real world, tracking time, pretty advanced, right? And apart from that, I mean, if you look out of Sri Lanka, when it comes to aspects like traffic management, there are like plenty of solutions. Like if you looked at the very novel solution which India introduced in terms of reducing the horns and preventing people from honking, those are very innovative applications of IoT. Talking about the telecom industry, the way I look at telecom is mostly an enabler of IoT. So telecom has a major role to play in terms of providing the network infrastructure. We know some telecom providers in Sri Lanka even experimenting with narrowband IoT, which will greatly enhance our ability to put these IoT solutions into very, let's say, for example, if you want to place a sensor on a road, that has to be very power efficient because we can't keep removing that from time to time to change batteries. And NB-IoT is something that drastically cuts down these kind of power consumptions. So I see telecom as a major enabler and has a huge role to play in IoT from that respect.
Perfect. And there's another input from the audience from Feroz. It says like in Sri Lanka, we are already working on smart street light system. Department has started. So these are real great stuff to know. And I mean, stemming from that same thing, that's about like street light or the traffic light system, or rather this is actually street lights, not traffic lights.
Correct.
Now, stemming from the same area, like the power grid of Ceylon Electricity Board, right? It's a massive machine, right?
Yes.
So how do you think like an organization like CEB can use IoT to minimize power outages, breakdowns, and like attend to some of these repair work faster? Do you think there's scope for it? And do you have any information as such that whether the CEB is already investing in such technologies?
Yeah, so I think Asanka can weigh in on this as well. So we know, I mean, as of late, the CEB did start introducing smart meters, which tend to receive a lot of data from these, and they're looking at real-time power consumption and things like that. And we know that there was a major movement towards solar power recently, where net metering and where the individual homes start feeding into the grid. And one of the major contributors to some of these power outages and this stripping is grid balancing, where they need to balance the output coming from the generators of power, as well as when all of a sudden power starts being generated from the homes. So this is a situation whereby kind of bringing all of this data together in terms of consumption, in terms of what's being generated through the grids, or the generators themselves, and taking remote action, like taking autonomous action on top of those, is a major place where the CEB can benefit from the Internet of Things. And I think they are looking in that direction as well.
We'll very soon we'll see, because I mean, I see that the present day situation we are facing in Sri Lanka is actually giving us a push to fast track digital transformation in many areas. So like we'll very soon see some of these organizations will fast look into this technology. So right now, we are fast approaching our time to closure for the day. But before that, actually, I'm going to read out one more question. Asanka, we don't need an answer for this question today because I know that this answer is going to get, this question is going to get answered in your next session. The question is, hi Asanka, how exactly could we do remote monitoring and management through IoT platforms itself? Can we do this? Now, this question, I'm sure it's going to be a topic for one of your upcoming sessions on Wednesday or on Friday. So whoever asked this question, it's an anonymous question. Please stay with us on Wednesday, right throughout to Friday. You will get this answer for this question. And at the same time, Asanka and Heshan, Isru, I'll hand it over to you to give a quick glimpse of what's up next. Like, I mean, what are we to expect on Wednesday and on Friday? Just quickly take a couple of minutes just to give us an idea about what to expect.
Sure. So today we've introduced everybody to the Internet of Things, right? And we're going to be talking, this session is more from a practical point of view, not necessarily how do you create an IoT solution. There's plenty of content out there for anybody who wants to try that out, right? But we as an organization who have practically put out IoT solutions, and especially Ishrat, who has been in the firing line when it comes to maintaining these IoT solutions, we're going to be talking about what it takes to actually keep an IoT solution alive. We'll be talking about some of the drawbacks. And as of late, having been, I would say, having been, having needed to work from home, how our teams have had to adapt and how the right tooling has helped us to actually overcome these problems compared to some of the, how other support teams have suffered due to not having the right tooling and the right way of thinking. So basically, in a nutshell, the two sessions are about how do you remotely monitor, troubleshoot, and manage an Internet of Things? What does it take to do that? How should you get about selecting your tools and training your people? And the next part is we'll focus on the same topic, but more towards the angle of work from home and how efficient tooling is actually essential for a work from home culture, which I'm pretty sure a lot of organizations, even after the COVID scenario, will be seriously considering to continue with.
All right. Thanks, Asanka and Heshan and Isru for joining in today. And for attendees, actually, we have quite a lot of questions, actually, an overwhelming amount of questions, close to about 30 questions, right? And we managed to actually answer most of the questions, but I'm sorry if we missed any questions that you posted. But stay with us for next Wednesday when we come to the second episode of this short online course on Internet of Things. So we are going to discuss a lot more interesting topics in a little bit like the deeper end of this topic of IoT. So until such time, we meet again on Wednesday, 7:30. So have a nice, wonderful evening, and thank you for joining in today. Bye-bye.
Thanks, everyone. Bye-bye.
Thanks, everyone. Bye.
Everyone.